Welcome to Wamlad Academy. If this is your first time, don't forget to hit the subscription button and turn on your notifications. Today, we want to talk about the physical quantities. What do we mean by physical quantity? Physical quantity is a number that is used to determine a physical phenomenon quantitatively. And this physical quantity is divided into two. You have what we call fundamental quantity and what we call derived quantity. What do we mean by fundamental quantity? Fundamental quantities are the quantity whose measurement does not depend on the other quantity. They don't depend on other quantity. They are independent. Example are mass, time, etc. And when I talk about derived quantities, derived quantities are the quantities that are derived from other quantity, e.g. velocity, volume. So what they mean is that this derived quantity, they derive for them from what? From the fundamental quantities. And you see how they call units. What do you mean by units? Unit is defined as the magnitude of physical quantity, which is very essential. And this unit as well is also like quantity. That means unit is also divided into two. You have fundamental and you have what they call derived unit. So in this fundamental units, it's almost the same thing as the definition here, that fundamental units are the units whose measurement does not depend on the other units. Why derived units are units that are derived from fundamental units. Let's now talk about this fundamental quantity. If you are talking about the fundamental quantity, we have 7 fundamental quantities. And what are these 7 fundamental quantities? Fundamental quantity. So the first one you have, we call it, let me do it like this. You have quantity, you have our unit here. So the first one here, we have called length. So this length is in fundamental quantities. And what the unit of this length is meter. So the unit of length can also be centimeter or Armstrong and stuff like that. But the SI unit of length is what we call meter. Let me write it for meter. So which is abbreviated as what? As M. The second one we have what we call mass. So what unit of mass? Mass is kilogram. Which is abbreviated as what? As kg. So the unit of mass can also be gram, but the SI unit is what? Is kilogram. The third one we have what we call time. What unit of time? The unit of time is second. While the abbreviated is what? As x. So which means the unit of time also can be hours, can be year, can be day, but the SI unit is what? Is second. We have another one which is temperature. So the unit of temperature is what? Is Kelvin, which is abbreviated as K. So it can also be measured, the unit can also be in Celsius or Fahrenheit. But the SI unit is what? Is Kelvin. We have another one which is luminous intensity. So and the unit of this luminous intensity is what? Is what we call candela. It's abbreviated as what? As CD. We have another one, we call it electric current. So the unit of this electric current, we call it what? Ampere. And it's abbreviated as what? As amp. And the last one, we call it what? Amount of substances. Amount of substances. So this amount of substances, the unit is what? We call it moles. This is abbreviated as what? As mole. So all these same quantities we have here, they are what? They are fundamental quantity. Any other quantity from these 7, they are known as what? They are known as derived quantity. So let's now discuss about derived quantities. Derived quantities, like I said earlier, they are derived from these fundamental quantities. For example, we have, let's say, derived quantity. Derived quantity. For example, 1, let's talk about the area. The formula to derive the area is what? Area is length times breadth. So now, if area is called length times breadth, what now be the unit? Don't forget, the length is in meter and breadth is also meter. Meter times meter, you have to have meter square. Now the unit of area is meter square. Then to another one, you have what we call velocity. This velocity, the formula for velocity is what you call it displacement over time. So what will be the unit of velocity? So while this is our displacement, this is when they are also related to length. That means they need to be what will be meter over seconds. That means that what as meter per seconds, or you can write it as what ms per minus 1 is the same thing, meter per seconds. Then to another one, you have acceleration. Acceleration. The formula for acceleration is what is velocity over time. And don't forget, we said to know the unit of this acceleration, you already know the unit of velocity, which was meter per seconds. Meter per seconds divided by time, which is seconds. So if this s goes up, you are going to have ms per minus 1 minus 1. At the end of the day, you are going to have meter per second square. So another example, you have what we call force. Our force, the formula for force is what? Mass times acceleration. In this mass and acceleration, unit of mass is what? You know, is kilogram, while acceleration is what? Is meter per second square. So in this case, you are going to have kilogram meter per second square. But you will wonder that most of the time you come across of anything related to force, they put Newton. Don't let this surprise you. You have what you call special name for some units. Like the case of kilogram meter per second square, it has a special name. What is that special name? Because it's what is called Newton. It's only not only force has the special name. For example, we still have another unit where you have per seconds. This per seconds is the unit for what we call frequency. So and that's the special name, which is called hertz. Another one, when I talk about the work, as well that work seen as what? Force times distance. You have force and distance, that's when you are going to have what? Your work. And the unit of force is what? Like this, you have Newton, distance is meter, you have Newton meter. But that special name, what is special name? The special name is what? Is joules. So there are some certain units that are the what? Special name, like the unit of force, which is Newton, which is same as kilogram meter per second square. The unit of frequency, which is per second, which is same as what? Hertz. The unit of work, energy, which is what? Newton meter, which is same as what? As joules. While we have something we call unitless, then they have no unit. Why they don't have units is that it's a case whereby what you have in the numerator will already cancel what you have in the denominator. In that case, you have no unit. Like when I talk about tensile strain, is what? Is a unitless. So that's about the physical quantity, about fundamental quantity and derived quantities. I believe you understand what we did today. So before you go, let me give you the one question to solve. Let's call this as snacks. Let's say you have momentum, you have impulse, and 3 you have torque. So for these 3 quantities, they are derived quantities. Find their formulas and what will be their unit. So drop your answer in the comment section. So if this is your first time, don't forget to turn on your notification and hit the subscription button. And don't forget to share this video to your friend. So that's all for today. Thank you. See you next.